Last week we looked at distributive property using the hands-on equation. Hands-on equation does a really good job at a lot of things. However, it's not great at showing negatives or showing like fractions and decimals. Today we're going to be kind of exploring that a little bit more, particularly with distributive property. If I have, let's say, 4 plus 6 in parentheses and then the 2 on the outside. Now when we looked at hands-on equations, I said what this really means is I've got two 4 plus 6's. So I've got 4 plus 6, and then I've got another 4 plus 6. That's essentially what it is. And then, so you have 4 and 6 is 10, plus 4 is 14, 14 plus 6. The result of that is 20. That is what we demonstrated using the hands-on equations. Now you guys also know order of operations. You know that you do whatever's inside the parentheses first. 4 plus 6 gives you 10, so it'll be 2 and then a 10 inside the parentheses. 2 times 10 gives you 20. So it's just proving another way to show that that's true. Today what we're going to be using is distributive property. What distributive property says is we multiply the term on the outside times each of the terms on the inside. 2 times 4 gives us 8. That's 8. Plus 2 times 6 gives us 12. And then when we combine those, we get the solution 20. Now each of those is showing the solution 20. Each of them in different ways. This is showing the hands-on equations, physically what that looks like. This is showing order of operations, doing whatever's in the parentheses first. And this is showing using distributive property. That is what we're doing mostly today. There is one other way. I just want to bring this to your attention because some people, they don't think about it this way. Sometimes that multiplication is on the other side. We get used to seeing it starting here and then the arch is going this way. But sometimes your multiplication will start from this side. Either way, it works the same. 3 times 2 gives us 6. Then there's a plus sign. 3 times 7 gives us 21. So your answer there is 27. Some people think of it as, well, 2 times 3 gives me 6, and then plus 7 times 3. Either way it works. The idea is that that number on the outside is being multiplied by both of the numbers inside. And remember, our commutative property, the order doesn't matter. The big advantage to distributive property is when there's variables involved. So if I have a problem that looks like this, and I have to simplify this. In order to simplify this, one way is to use order of operations, except for I can't add those together. These are my blue ponds and these are my number cubes. Those two cannot be combined. They're two different quantities, two different items. I could use my hands-on equations, and I could say I've got 3 x plus 3's. So I got 1, 2, 3 x plus 3's. That's what that means. Then I've got 1, 2, 3 x's plus 3, 6, 9 3's. All I did was the exact same thing we did with the hands-on equations. There's 3 of these. Here's 1, 2, 3 of them. So together there's an x, an x, and an x. That's 3, a 3, a 3, and a 3, and that's 9. It is much simpler and more efficient to use distributive property. 3 times our first term gives us 3x plus 3 times our second term, which gives us 9. Much more efficient to do it that way. I really like, there's a couple, so there's two ways to think about something like this. There's a subtraction problem in there. Some people don't mind the subtraction being in there, and they just solve it regular, like 5 times x minus 5 times 4. I personally do not like subtraction. I always change subtraction to addition and the next number into its opposite. We learned this in our second unit of school this year, way back before Halloween. Change subtraction to addition, the next number its opposite. When we do that, it makes the problem simpler. In this problem, it's not a big deal because I think we could do it both ways pretty simply. But for a lot of problems, it makes more difficult problems simpler. So, first thing we'll do is distributive property. That gives us 5x. Now, since I have addition, I can leave the addition inside there. And now it'll be 5 times negative 4, which gives me negative 20. And that's my answer. There are going to be people in here who don't want to change that. And I'm fine with that. If you have x minus 4, you do 5 times x gives you 5x. Now it's a minus sign, so you put a minus sign in there. 5 times 4 gives you 20. These two quantities are the same. Those mean the same thing. So either of those I'm fine with. But just recognize that you can change subtraction to addition, but the next number has a change to its opposite. Try this one on your own. Two parentheses 2y minus 7. Simplify that on your own. Anybody find it? Aiden, what'd you get? It sounds like you changed subtraction to addition. The next number is opposite. I love it. All right, and then we're going to do 2 times 2y, which gives us 4y, plus, because there's a plus inside there, 2 times negative 7, which gives us negative 14. Perfect. Try this one. That's a 2. Negative 3, parentheses 2 minus 3z. Anybody find that one? Scott?
F is 5 plus 9z.
Not quite. Julian? Okay. So I see what you did there. All right, so do change subtraction to addition, the next number it's opposite. Now what I have to do is I have to multiply each of those terms. So I'm going to do negative 3 times 2. Negative 3 times 2 gives me negative 6 plus, and then I'm going to do negative 3 times negative 9. I'm sorry, negative 3 times negative 3, which will give me a positive 9z. Now, Julian, when you did yours, you said you got minus negative 9z. Is that right? Yeah. So what he did was he did this. To minus 3z. What he did is he left it like this and then did the distributive property. So that gave him negative 6. And then minus negative 3 times 3 gives him a negative 9z. Are these two things the same? Yes, those two things are the same. They are the same. For me, this one looks a little bit cleaner, but they are the same. What?
So, like, since you have a negative 3 next to it, could you change negative 3 to a positive and put
No, because what this is saying is you're taking away 3 blue ponds from the number cube 2. So because you're taking 3 blue ponds from the number cube 2, you can't switch that and say 2 cubes from 3 ponds. It doesn't work that way. Okay?
Why is the 9 negative? If the negative 3 and the positive 3 equal positive 9.
You're saying down here, why is that negative? Because when we do this one, you don't have to. There's no rule that says you have to change subtraction to addition. So if I left this as subtraction, I would do negative 3 times 2 to get negative 6. That would stay subtraction, and now it would be negative 3 times that positive 3, which would give me a negative 9. Up here, I changed subtraction to addition and made that a negative, and now those when they multiply gives us a 9. Notice these quantities are the same. You could change subtraction to addition, and the next number is opposite. They're the same values. It's just in one we changed it, and in one we didn't. All right, here's the last problem. You do not have to write this down. You and a friend go on a camping trip. You each buy a backpack for $90 and a sleeping bag for $60. What is the total cost for the equipment? Write this using distributive property. That's the key.